talking about accessibility in project-based learning. Again, for any of you who have not joined previously, my name is Shelby Kapler. I am an assistive technology program specialist and the Accessible Educational Materials Project Coordinator here with the Wyoming Institute for Disabilities and the Wyoming Assistive Technology Resources. I can be reached at 307-766-5770, or you can email me at skapple1@uwyo.edu. So our learning objectives for today, we're going to discuss what is project-based learning. So I hope that you'll be able to define project-based learning by the end of this presentation. Identify at least two possible barriers to project-based learning, and then understand how we can analyze projects for accessibility. So we'll jump right in with what is project-based learning. So a lot like it sounds, project-based learning is when students complete a project in order to learn various skills, including problem solving, collaboration, and active engagement. Some of the importance of project-based learning is that students can develop these skills, talking about critical thinking, encouraging creativity and collaboration, and also introducing some real life skills and activities to students. So these skills are beneficial for all students, including those with disabilities. Some of the challenges that students might face with project-based learning do relate to some of their disabilities. So students with physical barriers may have difficulties accessing some of the materials. Many projects include components where students are manipulating materials or building something. So the students' lack of mobility or dexterity might make it difficult to complete some of these tasks. Students with cognitive barriers may find complex or abstract instructions to be difficult to understand, or may get overwhelmed with tasks if there's a lot going on. Students with communication difficulties may have difficulty working in groups or performing presentations, so there would probably need to be some accommodations made there. As well as students with sensory barriers. So vision or auditory impairments could also limit students' access to different types of projects or materials. And so we need to consider all aspects of the project as we're putting together the project and understand what it is that we're asking the students to do. So I do want to do a quick recap here. I know several of you have joined most of these sessions, and if you haven't, that's totally fine. But this presentation today is intended to be kind of a put it all together. So we'll be talking about project-based learning, and we'll actually go over a real example of a project and discuss that along the way. But over the last several weeks, we started out talking about accessible educational materials. So these are educational materials that are provided in alternate formats like Braille, large print, audio, or digital to students with print disabilities, which includes students with visual impairments or blindness, learning difficulties, or physical impairments. Then we talked about universal design for learning, which is ensuring that all projects and assignments, presentations of learning is made in the best possible way for each student to learn. So we want to offer multiple means of engagement, multiple means of representation, and multiple means of action and expression for each student in order to best show what they know and engage with what they've learned. And then over the last couple of weeks, we talked about creating accessible documents and teacher-made materials. So this is considering all aspects of accessibility, especially in digital accessibility. So considering the font type, style, color that we're using, color contrast, layout and formatting, adding alternative text to photos and images, and considering other accessible formats. So all of those will come into play today as we discuss a project. So this is a real project that a high school teacher in Wyoming has asked their students to do. So we will be discussing the bridge project. So for this project, students were asked to essentially construct a bridge using the cheapest materials, or making the cheapest and strongest bridge possible, given those constraints. They're supposed to design a bridge using the West Point Bridge software, as well as another software called MD Solids. The students will also create a scale model of that bridge and then run it through a bridge breaker machine to test the limits of the bridge and then analyze its failing points and present that to a panel of judges. So given that prompt, there are several different tasks that the students were asked to complete. The first, students were asked to design or decide on a truss design for their bridge. So students were in groups of about 3 or 4. One person was to begin the design of the bridge in the West Point Bridge software. Another student was to begin the design in the MD Solids software. Another student was to build the scale model of the bridge using the materials that they were provided, which included things like popsicle sticks and straws. And another person was to begin the media campaign. So like I said, students were to put together a presentation at the end of this project, and they actually presented it to a panel of University of Wyoming engineering faculty as judges. And then, the students would run it through the Vermeer Logger bridge truss machine and find out where the breaking points are to analyze that. So we want to break down each of the different components of this project. And then within each, kind of break that down even further. So what tasks does each of these activities entail? What barriers might be presented to students with disabilities, as well as how can we mitigate those? So real quick, I'm going to invite you all to participate. Please feel free to unmute yourself or throw input into the chat. But if you were to break down the different tasks, what would be the various components of this project? Any thoughts here? All right, so we can kind of go through it. Basically, I divided these different components down into what we just talked about. So working through each of the different software programs, constructing the physical scaled model, as well as putting together the media presentation. We can go on to the next slide. So the first component that I identified is using the West Point Bridge Design software. So I'll be honest, this is not something that I am familiar with exactly what the program is and how it works. But it is used to design models and simulations of the bridge in the software program. So on the left-hand side, I have screenshots, and this is some of the actual student work that was designed. So the left-hand side has kind of a simulation of a bridge going over a valley. It's kind of a 3D animated, and you've got a truck coming over it. There are red and blue lines to simulate the different structures of the bridge. And then on the right-hand side, there's both a 2D and a 3D model of what the bridge looks like. So putting together these bridge models using the software, what tasks might be involved, or what barriers might you notice for students with various disabilities? And again, feel free to type into the chat or unmute yourself.
Oh, Virginia put in the chat being able to see the colors.
Great. Yep, that's an important one. And I think not only the colors, but also some of the really fine details. It looks like you would probably need to be able to uh, construct with pretty good dexterity, drawing out these lines, putting them together. It looks like it could be pretty small and fine work. So great, you'll definitely need some visual acuity for these tasks. Using a computer would be a skill. Using the mouse, probably, I imagine, and the keyboard. Yeah, exactly. Any other thoughts on this one? Okay, we can look at the next slide. So the next component really is similar, I think, in a lot of ways. It's using a different software program called MD Solids to dive a little bit deeper into the bridge design. So this is more of a two-dimensional model of the bridge. And I believe it has the load capacities of each truss and beam and different component of the bridge labeled here. So it looks like it's a bit more mathematical, a little bit more technical. So are there any additional pieces of this component of the project that students would need to be able to do? Okay, so yeah, kind of like we talked about on the last slide, students would need to have the visual acuity to use this program, as well as the cognitive skills to understand how to use it. Um, do you think that students with communication difficulties would have any trouble using this software or constructing a 2D model, even if it were a different software?
Shelby, Virginia's raising her hand.
Oh, I'm sorry. Yeah, go ahead, Virginia.
No, I mean, just looking at it, so I'm like not a math person, and this would just overwhelm me looking at this. And I just can't imagine somebody else who, uh, yeah, I'm like I said, I'm not a mathematician by any means, but I've had some math, and I can see where that would really overwhelm somebody.
Exactly. And thank you for that. And please do feel free to just unmute yourself. I'm not, I don't see hands raised really easily. But thank you for that input. I'm right there with you. I'm not a mathematician either. And so, yeah, this could be very overwhelming. I understand that the students did have several weeks of lecture and note taking and learning before they started this project. So there was a lot learning up to that, leading up to that, excuse me. So I'm assuming the students probably knew what they were doing. But yeah, visually, this is a lot to look at. Cognitively, it's a lot to process. So yeah, considering those different pieces and trying to make those more accessible. There are some different technologies that we could use to help some of this. So if students had maybe a visual impairment, there are several different screen magnification options, built-in adjustments that could be made. Maybe the student would prefer seeing this inverted. So it would be like white text on a black background, and that might make it easier to see. Um, maybe that maybe there's a way to minimize some of this information so it was a little bit cognitively easier to process. For a student with a physical impairment, maybe using an alternate keyboard or mouse in order to make things a little bit easier to write or draw on the software. Again, I don't know the software. Maybe it could be downloaded onto a tablet and a student could use a stylus or like an Apple Pencil or something to produce the work that way. So there are different options to ensure that these pieces are accessible as well. Great.
I think about, I remember in a class once where we had to build a bridge using spaghetti noodles.
Oh,
And it was very simple, but it was also, because it was hands-on, much easier to learn the concepts. Um, I don't know, for me, it would just be a little hard. And I'm not a tech savvy person, so no math, no tech. I'm really lost.
no, that's okay. And that's a great point. So looking at our next component here, is the physical piece of actually designing the bridge and putting together that scale model. So this is an example of what this group of students put together. So I know they had access to large popsicle sticks, like fat popsicle sticks and thin ones, as well as straws. And I'm not sure what other materials they had access to. I'm assuming some kind of glue or tape. It looks like maybe might be balsa wood. I'm not positive. Um, so this brings up a whole new set of challenges. Thinking about a student with visual impairment or low vision, blindness. Is this something that they might be able to do? Follow that bridge design that they created in the software and actually create a full model of it? How about a student with a cognitive impairment? Students with physical disabilities? What kind of barriers might they have here, and how could we accommodate those?
This probably took a lot of dexterity and someone who doesn't have fine motor skills. It could be a real challenge.
Exactly. Yeah, I think, imagine a student, like you said, without great fine motor skills. I think they would have a challenge putting this together. But we do want to make sure that those students still have access to doing this part of the project. I have a feeling that in many classrooms, if a student isn't able to, doesn't have the dexterity to build this model, that they might be put on one of the more computer-based tasks, or a different task. So if they wanted to do this, how might we accommodate them?
They could also possibly use some type of material that was a little more flexible, because I would imagine that balsa wood would break easily. So
Definitely. Yeah, I think if a student with a physical impairment wanted to do this portion of the project, that yeah, you could certainly make accommodations for different materials. Maybe they make a larger scale model rather than a tabletop model. Maybe it's, a foot tall instead of, 3 or 4 inches. Considering different materials, maybe there are different assistive technologies that the student could use. If it's tremors, maybe it's using a weighted glove. So there, I think, definitely could be different ways to do this. What about a student who maybe has a visual impairment, and they're trying to build the scale model off of the bridge design from previous slides?
Well, the slides would be really hard for them to use as a model. So we'd have to figure out a way that they could feel, or depending upon their how much sight they do have, how to adjust it to that so that they could be successful with that, and um, being able again to use the material that would help them out.
Exactly. Yeah, I mean, we could think about tactile graphics. So maybe we can print out a tactile version of the um, model from the software, or draw it out with like puff paint or other types of markers. Maybe even doing, yeah, like a 3D printed scale model of the bridge rather than physically building it out of the popsicle sticks and things. Yeah, great. And we can move on to the next slide. So the last component of this project that I identified was doing the media presentation, the media campaign. So again, once the students finished up all the different components, they put this all into a slideshow and then presented it to a panel of judges as if they were trying to sell their bridge idea to a company. So in this example, a few of the students' slides I screenshotted, and they welcomed the judges. In another slide, they talked about the MD Solids software, how it works, what it does. They discussed their final design and the final price, because that was one of the constraints, is making the strongest bridge at the cheapest price. And then finally showing their test results. So where the bridge broke and why. So what kind of tasks would putting together this presentation entail?
Well, make sure that each student was successful, um, using their strengths for them. Because I would imagine that, there's probably one that is pretty strong with vocal and being able to present and things like that. But then they could also help that student that isn't as strong as of a presenter, and working together to do that.
Right. So this seems like an area where a student with a communication disability might have some difficulties. Yeah, so thinking about ways that that student could um, use maybe assistive technology or another form of presenting in order to share their thoughts and ideas. Also going back into kind of what we've talked about in the past is designing accessible presentations. Overall, this one looks pretty good with the white text on the black background. There are some sticking points, like the final price on the upper right-hand slide, where it's the white text on the green background. So yeah, putting to the actual presentation and bringing in those accessibility pieces, having the students present, and like we talked about, yeah, using their strengths. Um, the similar considerations as we just talked about with using the software and other computer programs, is putting together the slides in a PowerPoint presentation. Students needing to communicate within their group and to the panel of judges. Students with physical disabilities needing to access the computer. And then again, the cognitive load for students with cognitive impairments or their learning disabilities.
I think too, with the slide design, the graphics, the lines that are going through the design or whatever could be distracting from the actual presentation.
Yeah, I agree. And again, I'm not sure if this was a oh, what's the word? Like a template provided to the students by the teacher, or if this was something that the students chose. So if it was a template, yeah, having the teacher, consider that might be a problem area for students both putting together the presentation and for others viewing it later on. That's something definitely I think is worth teaching the students in advance, is considering accessibility as well as they go.
Yeah, because the slide about the software MD Solace, that yellow down at the bottom there, it distracts me away from the line.
Right. Yeah, I see what you're talking about, and that's fair. Yeah, thank you. Great observations. Okay, I think we can move on to our next slide. So thinking about this project and kind of breaking it down into those different components, are there other pieces of this project that we may have missed or not talked about?
I think it's difficult not knowing the children that would be doing this project, because of course we want to base it on their success.
Right. I think that's a really great point and something kind of to touch on as well. So granted, most teachers are going to know their students and each, their individual needs. And so that's a great way to be able to tailor a project to each of those students. But if we start thinking about, for example, higher education and larger size classes where that teacher to student ratio might be larger, and the professors don't know each of their students, there are a lot of students that may not disclose their disabilities or may have undiagnosed disabilities in the class. So I think that is something that's important to keep in mind when designing any type of project or group activity, is that we may not necessarily know who is in our audience. And so always designing our projects, our documents, our activities, whatever it may be, to accommodate the greatest number of people. Something else I thought about with this project is the teamwork and the collaboration involved. So all of the students do have to work together to create this project, which could certainly create barriers. Maybe if there is a student with a communication difficulty, all of the students learning how to work together and communicate effectively with each other. Similarly, students with maybe a cognitive or learning impairment, where it might take them a little bit longer to understand and process the material, or simply everyone just having different work ethics and styles. So, yeah, the component of that actual collaboration piece. Great. Well, I think that's it as far as this discussion goes. Thank you for your participation. And thanks to those of you who have continuously joined these sessions over the last several weeks. I hope that you have been able to develop some additional skills and think a little bit more about accessibility in education. So a few closing reminders here. We do have a survey, so if you could complete that, the link should be in the chat here shortly. We do appreciate those survey responses. If you are interested in staying in touch and keeping up on some of our future trainings and events, as well as different kinds of assistive technology that's available, please sign up for our monthly email dispatch newsletter. It just comes out once a month, so we try not to bug you too much. And lastly, for anyone who would like a certificate of attendance, we can provide those upon request, so just let us know.